there he is, captured for the first time on film, the winged god of Palenque. What the lens sees is so stunning that we must examine the details separately.
We see a man seated in a capsule, intently watching something. His hands seem to be operating some undefinable controls. His foot is pressing a pedal. At the rear of the capsule, we see jets trailing flames behind them. Isn't this a typical position for an astronaut, as we so well know it today? He seems to be dressed for the job, in trousers with a broad belt. A sort of jacket, tight-fitting at the wrists, like coveralls. The chair is well upholstered to absorb the shock of acceleration. A figure before controls, also dressed like an astronaut. Another jet trailing flames. This stone deity, say the Maya, represents Kukulkan, who came from the stars and returned there.
Quantum sensing is putting on the best pair of glasses that you can put on. So I need to put on reading glasses to read. Quantum sensing achieves the best possible image resolution that is allowed by the laws of nature as we currently understand them. But the underlying basis of those physical laws today in the year 2018 is quantum mechanics, and we don't know of anything, we don't understand anything. We humans don't understand anything better than quantum mechanics. You can't think of anything. The history of Bolivia in the 17th century, the price of eggs in Kazakhstan, there's nothing that we understand better than quantum mechanics. There's no experimental deviation from its predictions that have thus far been verified. So therefore, I, as a physicist, can say I believe it. It sounds like a religious statement, but I believe quantum mechanics is correct. And so that actually describes what physical objects do. And if we impress onto the physical object the information, that tells us what information can do.
And Richard Feynman gave an experiment to show how weak gravity is. Take a friend, maybe not a friend, to the top of a high building. Push them off. It takes all of the atoms in the Earth and their gravitational force to pull them all the way to the ground in maybe 100 meters, if it's a really high building. But electromagnetism stops them in a fraction of an inch. They don't even make a dent in the concrete. Because the reason I don't fall through the stage is not that it's solid, it's mostly empty space. But the electric forces of the electrons in my hand, or in this case my feet, are repelled by the electrical forces of the electrons in the stage. So just the electrical forces of the electrons in the stage are holding me up against the entire pull of the Earth. Gravity is
deserves to trust their intuition more than Einstein. And Einstein's intuition told him, like everybody's intuition tells them, that things are really there when you're not looking at them. Well, he was wrong, right? That intuition is incorrect.
But prior to this in 1999, the delayed choice quantum eraser experiment was performed. If I'm going to simplify and explain this complex experiment, we need to do so with a hypothetical scenario of modifying the original double slit experiment. Instead of placing the detector at the slit, it is placed past where the particles land. But just before the particles hit the film, it is pulled away and the camera captures the results after they went through the double slit. If they observe a wave, then particles went through the double slit as a wave. And just adding a measuring device doesn't cause them to collapse the particles. But if they collapse to a state of particles at the moment of detection, then even though they went through the slit unobserved and should produce a wave pattern, the very act of observing instantly transforms them into particles. But not only that, a back history is loaded up so that particles went through the double slit instead of a wave. Well, to the dismay of materialists, the results would display particles. Observation creates the existence of particles and loads up a back history so they went through the double slit as particles. Thus it follows particles do not exist unless there is an observer.
So we know that we cannot assume, to put it precisely, we know that it is wrong to assume that the features of a system which we observe in a measurement exist prior to the measurement. Not always, I mean in certain cases. So in a sense, what we perceive as reality now depends on our earlier decision what to measure, which is a very, very deep message about the nature of reality and about our role in the universe. We are not just passive observers.
Now, many have tried to get around this by trying to separate the quantum world from the macro world, but that was also falsified in 2010 by violations of the Legge-Guardian equality. And in 2011, Bruckner and Koffler showed that macrorealism does emerge from quantum physics, so you cannot separate the two. This should be obvious since double-slit experiments have been performed successfully with larger things like atoms or molecules, and experiments are being devised on how to do this with mid-sized proteins and viruses, and no one doubts the results will be different. Another escape route many materialists use is to hold to the many-world interpretations of quantum mechanics, which basically argues there is no collapse of the wave function upon measurement, but that every possibility splits off into different worlds. So every quantum probability actually does play out. They just split off into different worlds, and in each one I'm observing each different outcome.